Introduction to the manifold gauge set. The manifold gauge set serves as of the essential tool in the field of HVAC, heating, ventilation, and air conditioning, and refrigeration. Understanding how to effectively utilize this instrument can significantly impact both the efficiency of climate control systems and the quality of service delivered to clients. Mastering the manifold gauge set transforms your approach to diagnostics and repairs, enabling you to troubleshoot systems with precision and confidence. Safety precautions. Before connecting the manifold gauges, it's important to take the necessary safety precautions. Safety precautions. Wear protective gear. Always wear safety glasses and gloves to protect yourself from refrigerants and potential leaks. Work in a ventilated area. Ensure that you are in a well-ventilated space to avoid inhaling any refrigerant fumes that may escape during the process. Check equipment condition. Inspect the manifold gauge set and hoses for any signs of wear, damage, or leaks before use. Why this topic matters. The importance of mastering the manifold gauge set cannot be overstated. For technicians and HVAC professionals, this knowledge is crucial for performing accurate diagnoses. Understanding pressure and temperature relationships is key to identifying system issues. Enhancing efficiency. Properly using the gauge set can optimize system performance, leading to energy savings and improved comfort for users. Ensuring safety. Knowledge of how to handle refrigerants safely prevents accidents and promotes environmental responsibility. By acquiring the skills to use a manifold gauge set effectively, you position yourself as a knowledgeable professional ready to tackle a range of challenges in HVAC systems. A typical manifold gauge set consists of several key components, each playing a vital role in its operation. Manifold body, the central unit that houses the pressure gauges and serves as the control hub for refrigerant flow. Pressure gauges. These display both high and low pressure readings and are critical for diagnosing system conditions. Hoses, color-coded hoses, usually red for high pressure and blue for low pressure, connect the manifold to the system and the refrigerant source. Valves. Located on the manifold, these control the flow of refrigerant into and out of the system. Access fittings. These enable the connection of the manifold to the refrigerant lines on the HVAC system. Understanding these components will enhance your ability to use the gauge set effectively. Take a moment to familiarize yourself with these parts, as they will be crucial in the following sections. Setting up the manifold gauge set. Proper setup is essential for accurate measurements and safe operation. Follow these steps to set up your manifold gauge set. Inspect the equipment. Before use, check all components for wear or damage, ensuring that hoses and gauges are in working order. Connect the hoses. Attach the red hose to the high-pressure side and the blue hose to the low-pressure side of the manifold. Make sure the connections are secure to prevent leaks. Attach access fittings. Connect the other ends of the hoses to the system's access fittings, ensuring they are properly seated. Open the valves. Once everything is connected, open the valves on the manifold to allow refrigerant flow. By following these steps, you will set up your manifold gauge set for effective use in diagnosing HVAC systems. Common mistakes in setup. Even seasoned professionals can make errors during setup. Here are some common mistakes to watch out for. Incorrect hose connections. Always ensure that the red hose is connected to the high pressure side and the blue hose to the low pressure side. Neglecting to check for leaks. Failing to inspect hoses and connections can lead to refrigerant leaks, which are both dangerous and can affect system performance. By being aware of these mistakes, you can avoid them and ensure a smooth setup process. Practical applications of setup knowledge. Understanding the components and proper setup of the manifold gauge set directly translates to enhanced diagnostic capabilities in real-world applications. For instance, when responding to a service call for a malfunctioning air conditioning unit, knowing the correct setup allows you to quickly assess refrigerant levels and system pressures, leading to faster resolutions. Consider a scenario where you find low pressure readings. This could indicate a refrigerant leak, allowing you to address the issue promptly. Practice setting up your manifold gauge set in a controlled environment to reinforce your learning. Familiarity with the components and their functions will increase your confidence and efficiency in the field. Understanding pressure readings on the gauges are vital. It displays pressure in psig increments up to 350 psig with a vacuum reading in inches of mercury on the low side, allowing for precise low pressure measurements. Steps for connecting the manifold gauges. Follow these steps to connect the manifold gauges correctly. Prepare the system. Ensure that the HVAC system is turned off before making any connections. Connect the hoses. Attach the red hose to the high pressure port and the blue hose to the low pressure port of the manifold gauge. Ensure that the fittings are secure. Attached to the system, connect the other end of the red hose to the high pressure service port on the system and the blue hose to the low pressure service port. Open the valves. Once connected, gently open the valves on the manifold gauge to allow refrigerant to flow from the gauges. By following these steps, you will ensure a proper connection that allows for accurate pressure readings during diagnostics. Recognizing improper connections, being able to identify signs of improper connections is crucial for effective troubleshooting. Look out for the following indicators. Inconsistent gauge readings. If the gauges are fluctuating or reading zero when the system is operational, there may be an issue with the connections. Refrigerant leaks. If you notice hissing sounds or smell of refrigerant, disconnect the system immediately and inspect your connections. Frost or ice buildup. Excessive frost on the hoses or gauges can indicate improper connections or a refrigerant issue. If you encounter any of these signs, reassess your connections and ensure everything is secured properly before proceeding. Practical applications of connection knowledge. Understanding how to connect manifold gauges properly is directly applicable in real-world HVAC service scenarios. For example, when called to a site with an underperforming air conditioning unit, your knowledge of gauge connections will allow you to quickly assess whether the system is overcharged or undercharged based on the pressure readings you obtain. Being able to connect and interpret these measurements accurately can lead to faster diagnostics and more effective solutions for your clients. Consider practicing this process in a controlled environment or using simulation tools to reinforce your understanding of connections and their importance in HVAC diagnostics. Reading the manifold gauges accurately is a fundamental skill for any HVAC technician. This chapter focuses on interpreting the information displayed on the gauges, which is crucial for diagnosing system performance and identifying issues. By understanding how to read these gauges, you will be better equipped to make informed decisions regarding repairs and maintenance in HVAC systems. Understanding gauge readings. The manifold gauge set consists of two primary gauges, the high-pressure gauge and the low-pressure gauge. Each gauge provides valuable information regarding the refrigerant state and the overall health of the HVAC system. Here's how to interpret these readings. High-pressure gauge. This gauge typically shows pressures from 0 to 500 psi. A higher reading indicates that the refrigerant is under significant pressure, which may suggest that the system is overcharged or experiencing a blockage. Low-pressure gauge. This gauge usually displays pressures from 0 to 100 psi. A low reading can indicate that the system is undercharged or there may be a refrigerant leak. In combination, these readings provide a snapshot of the refrigerant cycle and help assess whether the system is functioning optimally. Interpreting pressure readings. To effectively diagnose HVAC systems, it is essential to understand how to interpret both high-pressure and low-pressure readings. Normal operating pressures. Familiarize yourself with the normal pressure ranges for the specific refrigerant used in the system. Each refrigerant has its own set of standard pressures at various temperatures. Identifying issues. Use the pressure readings to identify potential problems. If the high-pressure gauge reads significantly higher than normal, it may indicate a blockage in the system or an overcharge. If the low-pressure gauge reads lower than standard, this could suggest a leak or insufficient refrigerant levels. Temperature correlation with pressure. Understanding the relationship between temperature and pressure is vital. The pressure readings on the gauges can be cross-referenced with temperature data to achieve a more accurate diagnosis. This relationship is defined by the principles of thermodynamics, where pressure increases with temperature in a closed system. For instance, if you are working with R410A refrigerant, knowing the saturation temperature at which the refrigerant boils at different pressures can help you determine if the system is functioning correctly. Use a pressure temperature chart specific to the refrigerant to make these assessments. Applying gauge readings to diagnose issues. Once you have mastered reading the gauges and correlating them with temperature, you can apply this knowledge to diagnose common HVAC issues. Overcharge. If the high pressure reading is excessively high, combined with a low suction pressure, it may indicate that the system is overcharged. Undercharge. A low pressure reading may suggest that the system is undercharged, often due to a refrigerant leak. Blockage. A significant disparity between the high and low pressure readings may indicate a blockage in the system, necessitating further investigation. By analyzing these readings, you will be able to pinpoint issues effectively and determine the necessary corrective actions. Practical applications of reading gauges. In real-world applications, being proficient at reading gauges can lead to quicker diagnostics and more efficient repairs. Consider a scenario where you are called to service a malfunctioning refrigeration unit. By quickly connecting your manifold gauge set and accurately interpreting the readings, you can determine whether the issue lies in an overcharge or a refrigerant leak. This not only saves time, but also enhances customer satisfaction through effective service. In the world of HVAC, tools are everything. And one tool that's changing the game is the digital manifold gauge set. Let's break it down so you can see why it makes diagnostics easier, faster, and more accurate. Unlike analog gauges, digital sets do the hard work for you. They automatically convert pressure into temperature so you don't have to flip through a PT chart. The display shows low side and high side pressure, saturated temperature, and in many cases, superheat and subcooling calculations right on the screen. At first, the buttons might seem intimidating, but with a little practice, you'll quickly learn how to change refrigerant type, switch between Fahrenheit and Celsius, and even record your readings. Think about how much time you save. With analog gauges, you calculate superheat and subcooling manually. With digital, the numbers pop up instantly. Some models can even store readings or connect to your phone. That means better reports for customers, proof of your work, and easier warranty claims. Remember, digital gauges need care. Always check your battery before heading to a job. Calibrate when needed and keep them safe from drops or moisture. Here's the key: digital gauges are faster and smarter, but you still need to understand the basics. Always train on analog first, then move to digital. That way you'll know the science and trust the screen. Digital manifold gauges, making HVAC diagnostics quicker, easier, and more accurate. Master them, and you'll be one step closer to becoming a confident HVACR technician. Saturated refrigerants play a vital role in HVAC systems where both liquid and vapor states coexist. These refrigerants are key in sustaining the efficiency and operation of the systems. Their distinct pressure-temperature relationship is an interesting feature illustrated through PT charts. These charts are essential tools that help technicians and engineers conduct precise diagnostics and maintain optimal system performance. Understand what saturated means. A refrigerant is saturated when it is at the point of changing state, either boiling, evaporating in the evaporator, or condensing in the condenser. At this point, pressure and temperature are directly related. That's why we use a PT chart. Use a pressure temperature PT chart. Every refrigerant R22, R410A, R134A, etc. has its own PT chart. Find the pressure you measured with your gauge. Look across the chart to find the corresponding saturation temperature. Example: suction pressure R410A system equals sign 118 psi. PT chart shows that 118 psi equals sign 40 degrees Fahrenheit saturation temperature. Analog gauges method. On a compound blue gauge, you'll often see inner temperature scales next to the pressure scale. Line up the refrigerant type with the pressure needle. The scale gives you the saturated temperature directly. Digital gauge method. Digital gauges do this conversion automatically. You just select the refrigerant type, R410A, R22, etc., and the display shows both pressure and saturated temperature together. Apply to superheat and subcooling. Superheat measures suction line temp, subtracts saturated temp from PT chart or gauge. Subcooling measure liquid line temp, subtract saturated temp from PT chart or gauge. Join us in the journey of mastering HVAC systems. Together, let's ensure every system we touch operates at peak performance, benefiting both us and our clients. If you found this helpful, hit like, drop a comment, and subscribe for more HVACR tips and training. Use this example as practice and apply it in the field.